solving quadratic exponential functions. So, working with exponential equations still, but we're going to look at exponential equations that have three terms. In other words, they are a trinomial. And when there's three terms, typically what we can do is we can factor, but we need to use a little bit of substitution before we get there. And I have a list of steps here to kind of help us work through these problems. And the first step is to check to see that all terms with a variable in it have the same base. And if we have the same base, we're good. If we don't have the same base, we're going to have to adjust it so that we do have the same base. Step 2, we're going to pick an arbitrary variable to represent the base and exponent, but you can't use x or e. If you don't like the letter that I'm going to use, which is u, then use something else. It doesn't make any difference as long as it's not x and it's not e. Third step, we're going to replace the bases with the variable that we choose. We're going to factor and solve. Then we're going to replace our variable with our value that it actually represents, and we're going to solve for x. So lots of words there that people sometimes don't even listen to because there's so many words. Speaking of Jalil, who told me that. So he waited until almost the end of his senior year to tell me that. And I did not take it personally. Step 1, we need to make sure that we've got the same base. And in this problem, we actually do have the same base. And our base happens to be e to the x. And a little trick that I use, and it's not always the case, but oftentimes it is the middle term. It says minus 16e to the x. The middle term often has the base that we need to use back in the problem. So once we determine that we have the same base, then what we're going to do is we are going to let u equals e to the x. Again, if you don't like u, then pick another variable.
Doesn't matter.
Don't use x, don't use e. Other than that, you can pick a different variable. Frequently in calculus, they do use what's called u substitution. So I want to at least introduce it to you. So once we determine that we're going to let u equals e to the x, we're going to rewrite our equation here. And e to the 2x becomes u squared. Because e to the x is the u part, and then it's also got a 2 on there. Minus 16u, again, e to the x, we're representing it with the u, plus 15 equals 0. That leads us to step 4. Now that it's in this format, hopefully it's a fairly straightforward factor. And u squared is u times u. And factors of 15 that combine to be 16 are 15 and 1. Minus 15 minus 1. Well, it says factor and solve. So I hope that you could say, well, u equals 15 and u equals 1. But if you can't, we take u minus 15 equals 0. And u minus 1 equals 0. And once again, we add the 15 to both sides. So we get u equals 15. And u equals 1. That's step 4. We factored, we solved for u. Well, we don't care what u equals. but we do want to use those values to help us get our final result here. Replace and solve for x here in step 5. Remember that u is being represented by e to the x. U equals e to the x. So instead of u, let's write e to the x equals 15. And e to the x equals 1. And now we're going to solve here. So that's our exponential. And because there's an e in this problem, I recommend using the natural log, but you can use the common log if you like. But it's the natural log of e to the x equals the natural log of 15. And we're going to use our power rule. Our power rule stating that we can take this value of x and write it out as a coefficient. So we have x, natural log of e, equals natural log of 15. And do you remember what natural log of e equals? It does equal 1, and if you can't remember, you can type it in. Natural log of e does equal 1. So ultimately over here on the left side, this is x times 1, which is x, equals natural log of 15, which is our exact answer. And then if we want to know the decimal approximation, we can simply type in natural log of 15, 2.7081. Now, remember, we have e to the x equals 15, but we also have e to the x equals 1. Well, any number to this power equals 1. What is that number? And if you don't believe me, check it on your calculator. E to the 0 equals 1. So our two solutions to this problem. Here's our exact. Here's our decimal approximation. And we don't need a decimal approximation there. That's our exact. So we have two solutions, which makes sense with it being a quadratic exponential function. There's a squared in the problem. So let's try another. They're usually fairly straightforward, but we need to get used to the steps. The first step being, do we have like bases? And if not, can we adjust it so that we do? And once again, it doesn't always work, but it oftentimes works. We do have same base. If we look at the middle term here, the 3 times 2 to the x, it looks like 2 to the x is going to be our base. So step 2 says that we're going to let u, or whatever variable you pick, equal to the x. And we're going to substitute this back in. But I do want to rewrite this problem a little bit to put it in quadratic form here, and I'm probably going out of order on my steps. But let's move the 28 over to the other side. And we have 2 to the 2x minus 3 times 2 to the x minus 28 equals 0. And again, we're going to substitute in the u, but I do want to rewrite one more thing that some of you may need to do and some of you might not need to do. But this can be rewritten as 2 to the x squared. Because remember, the power rule there the superpower, as I usually call it, means that we would multiply these two together. X times 2 is the same thing as 2 times x. And again, you don't necessarily need that step, but just in case. Because we've identified the base, we've set up our u, so our third step is to substitute, which means that this becomes u squared minus 3 times u minus 28 equals 0. We're going to factor for our next step. Much easier to factor with u's than the 2 to the x's. And it's u and u, 7 and 4, minus and plus. And again, I hope that you can just tell me that u equals 7 and u equals negative 4. But if you can't, the way that we get that is u minus 7 equals 0. So we get u equals 7. U plus 4 equals 0. So u equals negative 4. So that was step 4. We factored and we solved for u. But we need to use those values to really solve for x, which is our ultimate goal. And remember that in this case, our u is really 2 to the x equals 7. And over here, it's going to be 2 to the x equals negative 4. So we need to use our techniques from solving our functions where we can put in a log on both sides. Then we'll use our power rule, which says that that x doesn't need to be an exponent. We can rewrite it as a coefficient. So it becomes x log 2 equals log 7. We want to solve for x, and since it's x multiplied by log 2, we can use our inverse operation and divide by log 2. So our exact answer here is log 7 divided by log 2. That's the exact. If we get our decimal approximation, let's type in log 7, close the parentheses, divided by log 2, close the parentheses. And we get this value of 2.8074. But before I go ahead and solve 2 to the x equals negative 4, if you look at the directions here, it says check your work using your graphing calculator. So we just have that answer in our calculator, so before it gets all jumbled up, what I'd like to do is just show you a way to check here. And our problem was 2 to the 2 times our answer there, which we can take on our calculator and go second and the negative button. And it's going to take our value, log 7 divided by log 2. It's taking this value and it's putting in here. Arrow, right arrow, minus 3 times 2 to the, well, again, we need that answer. So second answer. And when we press equals, hopefully we get 28. So we know that we have at least that part of the problem correct. But we still do have one other side here. We have 2 to the x equals negative 4, and we can go about the process the same that we did earlier. We can put a log in on both sides. But we have a problem on this. What does this value have to be? This value has to be positive, but it says log of negative 4. Well, because negative 4 is not allowed to be in that position based on our domain, then we don't need this part of the problem right there. I mean, you could say extraneous, but extraneous is actually a problem, an answer that looks good that doesn't work. We can't even get an answer on this. When we type it in, we get log of negative 4. We get error, non-real answer. So I usually cross it out. I guess you could say no solution over here. I don't typically write anything for an answer for this part because we can't even work the problem out based on our domain. I just cross it out, something like that. So our true answer here is what we ended up with a couple of minutes ago, which is right there. So hopefully it's starting to see a pattern, at least in terms of how to solve with our steps. And once again, when we look at these problems, what we want to identify is, do we have the same base? And as we look at that middle term there, it seems there's an e to the x in there. Let's say that we have a same base. And our base is going to be e to the x. So step 2 then says let's let u equal e to the x. Again, if you don't like the letter u, use something different, not x, not e. But when we rewrite the problem, again, if you prefer, you can rewrite e to the 2x as e to the x squared minus 4 e to the x plus 3. You do not need to do that step, but for some people who are very visual, it will make more sense as we go into step 3, which is our substitution, which says that we're going to write this as u squared minus 4u plus 3 equals 0. Factor and solve, our next step. And again, I hope that you can tell me that u equals 3 and u equals 1. Where they're coming from. U minus 3 equals 0. U minus 1 equals 0. Plus 1 plus 1. U equals 1. And now that we've got that, we've solved for u, but we really want to solve for x. So we're going to put our values back in here. This time it's e to the x is what u is representing. E to the x equals 3. And e to the x equals 1. So as we get close to finishing this problem, because there's an e in this problem, I recommend using natural log. So it's natural log of e to the x equals natural log of 3. We still want to use our power rule, which says that we can take this x and we can write it out as a coefficient here. So we have x, natural log of e, equals natural log of 3. But let's recall that the natural log of e is 1. That's the nice part there. So this is really x equals the natural log of 3. That's our exact answer. If we want a decimal approximation, without typing it in up here, it's 1.0986. But remember, these are quadratics, so there's oftentimes more than one answer, because a quadratic has a squared term in it. But luckily over here to the right, e to the x equals 1, e to what power equals 1? Any number to 0 power equals 1. So our two answers, once again, are here and here. Remember that we can check these answers back in our calculator. I'm not going to spend the time on doing that, but you could, after class, later on, type it in your calculator and check to make sure that it works. When you're taking a test or a quiz, you have the ability to check and make sure that you've gotten the problem correct. But as we finish here with our last couple of problems, they're starred, and it's not because they're harder, it's just that they're written in a little bit different form from the way that we had them written before. We need to determine what the base is, and it's not so straightforward on this particular problem on 4 and 5, not so straightforward of what it is, but as we look at the middle term here, again, the 4 to the x plus 1, can we rewrite 16 in terms of 4? And that's what we need, where we need to start. So we're going to rewrite 16. It's 4 squared to the x minus 4 to the x plus 1 equals -3. Well, we need to do something with that middle term. That 4 to the x plus 1 isn't going to help us solve the problem too much. But if we can remember back to our exponent rules, a to the m times a to the n equals a to the n plus n. We can break apart that second term into 4 squared to the x. 4 to the x times 4 to the 1. Because once again, when we multiply terms with exponents, as long as the base is the same, we add the exponents. That's what this a to the m times a to the n is, a to the n plus n. We don't have to write it as 4 to the x plus 1. We can break it apart. If we actually multiply those together, we would end up with that. And even though I didn't show my work here, I'm going to move that 3 over to the left side there by adding 3 to both sides. So a lot of preliminaries here. In fact, I'm going to do one more preliminary step before we look at our like base. But I'm going to rewrite it as 4 to the x squared. Again, 2 times x times 2 is the same thing. So those two represent the same values. But it might help in terms of identifying what we want to let u equal. And now that we have it written out a little bit better, again, my technique works. we had to do a little bit of extra work, but if you look at that middle term, it's 4 to the x, and that's what's going to allow us to use our u substitution. So this becomes u squared minus u times 4 plus 3 equals 0. Written a little bit better, it's u squared minus 4u plus 3. And unfortunately, I used the same values in problem 3 and 4, which makes our factoring a little bit easier here. We don't get the same answers necessarily. Got minus 3 and minus 1, which ultimately means that u equals 3 and u equals 1. We did the work on that last problem, on problem number 3. We don't need to do that again. But here's what's different. We had a different value of u. So when we go for our last step here, which is to solve for x, we need to put the value of 4 to the x back in here for 3. And 4 to the x back in there, sorry. 4 to the x equals 3. 4 to the x back in for u. 4 to the x equals 1. 4 to the x back in for the u. And now we can solve. And we can use our common logarithm. We can use our natural logarithm. It doesn't make any difference. We get log of 4 to the x equals log of 3. Our power rule says that we can take this value of x and write it as a coefficient. And it's x multiplied by log 4, so the inverse operation is to divide by log 4. And so we end up with our exact solution of log 3 divided by log 4. And if we were to type that in, we would end up with 0.7925. Don't forget, it's quadratic here. And we oftentimes, with the quadratic, will have two solutions. We've got that 4 to the x equals 1. But luckily, we don't have to do so much work because any number to this power equals 1. What is that number? It's 0. So one more to illustrate the process here. And again, identifying the base is the secret. But do you have a gut instinct here? As you look at this problem, can you look at that and go, oh yeah, I know what u is? Because after you do a couple of them, you usually do. You have any idea what u might represent? To the x. I'm going to do a little bit of preliminary again. But as we look at the middle term, it's a 2. Can we rewrite 4 in terms of 2? 4 is 2 squared. We can break up 2 to the x plus 1 as 2 to the x times 2 to the first. And we have the minus 35 already in the place where we want it to be. I'm going to switch this around and rewrite it as 2 to the x squared plus 2 to the x times 2 to the first minus 35 equals 0. And now we can use our u substitution. And we could have conceivably done it sooner, this is u squared plus u times 2 minus 35 equals 0. A little bit better format. U squared plus 2u minus 35 equals 0. So that leads us up here now to step 4, which is to factor and solve for u. Uh, 7 and 5 plus 7 minus 5. So u equals -7. And u equals 5. And I did some extra work, but I hope you don't have to do any extra work. I hope you can go directly to that. And now we're going to take our value for u, which was 2 to the x equals -7. And 2 to the x equals 5. And now we can solve this. Once again, when we put a logarithm in over here on our answer to the left, the thing is, this value of our logarithm, sometimes called an argument, must always be positive. And because it is negative, we cannot work that problem out at all. So we don't need this part of the problem. We only need this 2 to the x equals 5, which I'm going to scoot over a little bit more. Our 2 to the x equals 5. And on this one, we can put in the log. We can use our power property, which says that we can bring this x out in front. So we have x log 2 equals log 5. And then it's x multiplied by log of 2. The inverse operation is going to be division. So we're going to divide by log of 2. So our exact answer then becomes log of 5 divided by log of 2. And if we were to type that into the calculator, it ends up to be 2.3219. Did we have to round that down?